Well, thank you for the introduction, and thank you for the opportunity to participate in the Practical Farmers of Iowa Conference. My name is Donald Lewis. I'm a professor of entomology here on campus and an extension entomologist. And if it seems like you have seen me before, it's because I have just passed my 40th anniversary at Iowa State University. So it's a job that I promised my wife in March of 1977 that we would try for a couple of years. And it was a good fit, and so the couple of years have now stretched into 40, and I'm sure this group is going to challenge me to use every bit of every answer I have learned or made up in those past 40 years, and we'll see what we can do as we go along and talk about the ecology and the management of just some of the common insect pests. I've made a list of things that I'm going to talk about, but we'll certainly save enough time to cover whatever you want. And we'll also take questions as they come up. Don't wait till the end. If something triggers your imagination and you have a question, let's just take it right then. As a professional entomologist, I'm required to start every presentation with a review of the insect life cycles, because everything we talk about in insect management, everything we talk about in insect behavior comes back to understanding where did they come from, how did they get here, how did they reproduce, why do we have them in this spot at this time. So some insects like beetles and moths and ants and bees and wasps have a complete life cycle of 4 stages: egg, larva, pupa, and adult. Of course, when we're talking about flies, we call the larval stage maggot. But when we're talking about butterflies, we call the larval stage caterpillar. So there's some other terms we might use, but this is the generalization of egg, larva, pupa, and adult. The caterpillar or the larval stage is usually the feeding stage, and that's the one we need to predict. That's the one we need to know about. That's the one we need to find in order to initiate controls at the right time. But it's also just a beginning. It is the feeding stage that's going to transform through the pupa stage into the reproductive stage. Only adults can reproduce, only adults can mate and produce more eggs to start in the next generation. And there's some interesting questions that come out of this, like, how long does this take? How long does it take to go from egg to larva to pupa to adult? And how fast does that happen in the summer? How many of those do we get in the summer? Well, the answer to that and all of life's difficult questions is, it depends. It depends on which insect we're talking about. It depends about the weather and a whole bunch of other things, how long this takes and how long it goes around. So beetles have this kind of life cycle, the flies, the butterflies and moths, and the ants, bees, and wasps. Everybody else has a simple life cycle of only 3 stages: egg, nymph, and adult. And in this case, the nymph is an immature that looks like the adult, only smaller. It doesn't have wings, and it cannot reproduce. So the quintessential example of that, of course, is the cockroach, but it also includes the grasshoppers and crickets, and it includes the aphids and all of their relatives. So this simpler life cycle of only 3 stages, egg, nymph, and adult, we find in a few of our vegetable production pests, but maybe fewer than in the other one. So that background always sets us up to talk about what's coming next, what are we going to do about these pests. This is the short list that I produced of talking about just some of the common insect problems that I've seen over the last couple of years, other questions that people have asked me about. If we have time, we'll talk about brown marmorated stink bug, which is not yet a crop pest in Iowa as far as we know, but we want you to be looking for that and let us know if you see it. So this is the list I'm going to talk about. If your insect problem is not on this list, there will be time at the end to go over that. And I just learned you've got an hour break when I'm done, so we really have till 3 o'clock to answer questions if you wanted to, but I don't think we'll last that long. Well, let's start with an easy one that everybody recognizes. The tomato or tobacco hornworm is a common problem. Some years, not others. It's a problem only occasionally, and it's one that is easy to recognize because it's a caterpillar that's about 4 inches long. It's as big around as your thumb. It's eating a leaf an hour off of your tomato plant, and then they have a little horn on the end of their abdomen. That little horn is harmless, by the way. One of the myths out there is, oh, don't touch those hornworms because they'll sting you. It's not a stinger, it's just a little fleshy protuberance off the end of their body. So it's one that's easy to recognize, and it's easy to find when it's big. But of course, little tiny eggs don't hatch into a 4-inch long caterpillar. Little tiny eggs hatch into a 3/16 inch long caterpillar that has to eat and grow and molt several times until they get to the size where you usually find them and usually recognize them. There are 2 species in the world of tomato hornworm. One is technically called the tobacco hornworm, and the other one is called the tomato hornworm. The one that I see more often in Iowa than anything else is the tobacco hornworm. So we call it tomato hornworm, and that's fine. You can get away with that. It's on your tomato crop. You could probably call it Chester, and it would be okay. So we call them tomato hornworms, but there really is this difference. They will also be found on eggplants, potatoes, and a few other related plants, but it's really the tomato crop where we find them most of all. So the little mnemonic device that I use to tell tomato hornworms from tobacco hornworms, of course, the stripes are the stripes are different. We should be able to do it that way. But the tobacco hornworm has a red horn, red like the end of a burning tobacco cigarette. That's how I remember which one's the tomato hornworm and which one's the tobacco hornworm. The tomato hornworm has a green horn, like fried green tomatoes, so I can keep them straight that way and keep myself out of trouble most of the time. Again, they have a complete life cycle like all the moths and butterflies do. The adults appear in mid-summer, kind of that period, May, June, July sometime, but it is highly variable when those moths are going to appear. They are night flying. They will not be out during the daytime when you see them. If you want to find them, you're going to have to go out and visit the tomato patch late at night. They're a fairly large moth, so 4 to 5 inch wingspan puts them pretty big size for an Iowa insect, and one that you would recognize if you saw it, but you're not likely to see it very often. While they're out there flying through the garden, once the female and male have mated, the female begins to lay her eggs on tomato plants, and this is one of those miracles of the insect world. She's got the whole county with all the plants in the county where she could lay her eggs, but she's going to look and search until she finds a tomato plant on which to lay her egg, because her offspring require that plant for their growth and development. So why are tomato hornworms on tomatoes? Why aren't they on cabbages? It's because the female chose to lay her eggs on the crop where the offspring would survive. It's a coevolution that occurred over the millennia, that the female picks out the right crop for where to lay her eggs. She just lays eggs individually, which is why we generally find hornworms scattered in the production area, but sometimes they'll be a little more clustered. Those eggs hatch after a week into real teeny tiny hornworms that are the color of the tomato crop and are going to be very hard to find. They grow for only a period of 3 to 4 weeks, and at the end of that 3 to 4 weeks, they're going to drop to the ground and burrow into cracks or crevices in the ground where they transform into the pupa. Now, 3 to 4 weeks doesn't sound like long enough to cover the whole summer. And what's really happening is the moth is laying eggs over an extended period of time. So you don't get all the hornworms at one period and then nothing. You get a few, you get a few, you get a few. And so they tend to straggle out. But there's really only one generation per summer. Once the pupa has formed in the soil, it will stay there until the following spring. Then the moth will emerge and come out of the ground. You can find these pupae in the soil, and they're easy to recognize because of this jug handle that's on the end of this 1.5 inch long bullet-shaped thing that you dug out of the ground. And inside this pupa, what was a caterpillar has been digested, and the proteins, the amino acids, the fatty acids, the carbohydrates are being reformed, rebuilt to make the adult moth. And this jug handle will be the proboscis of the adult moth. I don't know why it's out there loose like that. It seems like kind of a risk to stick your tongue out underground where it might catch on something. But it's an easy way to identify those hornworm pupae when you dig them up out of the ground. So they're out there underground now. They are doing fine because they're just anywhere from 2 to 6 inches deep, depending on how deep the crack was. Which brings me to the question that comes under the category of optimistic wishful thinking. It's been really cold this winter. It's been below zero. We've had minus 20-some degree wind chills. That's great news because all the insects froze to death, right? No. The insects will be back. Don't worry about it. The winter weather has very little effect on insects that are adapted to our climate, especially things like white grubs and hornworm pupae that are in the ground. They're covered with a blanket of snow. They have not experienced the minus 20 wind chills, and they wouldn't experience wind chills even if they were above ground. So the winter has not reduced the insect population as much as we might hope. Okay? So what do you do about tobacco hornworms? Most of you are able to get by on hand picking on the few years that they do show up. You could use spraying if you had a lot of them. The problem is the insecticides are not going to work well on the 4-inch long caterpillar that's easy to see. And that's especially true if you're using an organic product like Bacillus thuringiensis, abbreviated BT. That would have worked very well against those little tiny caterpillars that you didn't see coming, but it's not going to work against the large ones. So we're kind of in a bind here that sprays aren't going to work very well. Unfortunately, we don't have to control them all that often, but it's one that you need to watch out for. And if you start seeing a lot of them, you start looking for the little ones, knowing that your spray might work, be useful to you then. Okay? Every once in a while, you find a tobacco hornworm that's covered with these little white growths, these little white fuzzy things on the top. Those are the pupae. Remember, egg, larva, pupa, and adult? Those are the pupae of a tiny wasp. And this is straight out of the movie Aliens with Sigourney Weaver, that wasp was able to lay her eggs inside the body of the caterpillar. Wasp eggs hatch into wasp larvae that then eat the innards out of the hornworm. So there's this foreign life form growing inside the tomato hornworm. When the wasp larvae are fully grown, they get ready to pupate, and they do so by coming to the surface, burrowing through the exoskeleton of the caterpillar, and forming a cocoon, a pupa, on the outside of the caterpillar's body. People look at these and think of them as eggs. No, this is the cocoon. This is the pupal stage of that little tiny wasp. This is interesting, this is fun. The caterpillar that was infested with the parasites is dead. It's not going to finish its development. It's not going to be a reproductive member of its society. But that doesn't do much for the tomato hornworm population in the state of Iowa. It's fun to see it. It's nice to leave those. It's not going to make much difference if you do or don't. And there's really no way to push them to do more than they're already doing. It's going to happen when you stand back and do nothing, and it's going to continue be at that level. Okay? One question about hornworms, sure.
So what are the adult moths predominantly feeding on?
The adult hornworm moths? Yeah. Adult moths and butterflies have what kind of life cycle? They have what kind of mouth part? Siphoning. It's a long proboscis that generally coils up under their chin, if insects had a chin. Okay? And then they uncoil that and they poke it down, and mostly they feed on nectar. One of the interesting things about insects is all of their eating and growth can be done in the immature stage, and they get to the adult stage, they really don't need to eat much anymore. Unlike us, we're going to keep eating forever. Insects can get by on what they ate and stored as immatures. But they need a little energy, they need a little boost of sugar, and they get that from eating nectar out of flowers. You'll see moths occasionally feeding on decayed fruit, but again, they're sucking up or they're siphoning up a fluid. Yes?
What's that wasp species, and is there a way to encourage them around?
Yeah. It's a braconid, B-R-A-C-O-N-I-D, and I think it's braconhebitor. Someone Google tomato hornworm parasite for me and we'll get the name. I don't think you buy these. I think they just are here. Can you encourage them? I think the only thing you could do is leave these to live. When you're picking off tomato hornworms and you come to one that seems a little flaccid, you come to one that seems like it's not quite right, leave it. But as far as pushing more, I don't know that you can. Anybody ever try? Okay. Jumping ahead to cucurbiturils. Yeah, was there a question? Yeah. Mhm.
large, and it was very successful. Maybe it was more concentrated than usual, or I sprayed a lot of iron. It was very successful.
Mr. Lucky up here on his way to buy a lottery ticket says that when he sprayed BT on larger hornworms, he thought it worked. They have to eat it to be affected by it. Bacillus thuringiensis is a bacterium that produces a protein that paralyzes and penetrates the gut of the caterpillar stage. So in order for it to work, they have to get it in them, and they get it in them by eating. So if the larvae are still eating, there's a chance that it may work. But the effectiveness is much less than it would have been on the small ones. Yes?
Is there a way to use degree day turning to time applications for this and the other pests that you're going to talk about?
Degree days are not as well worked out for vegetable pests as they are for some other things like field crops, and a lot of that just has to do with the amount of research. The other thing that's a problem with degree days is you need a point to start counting. And for some things, we do that by capturing the first adult moth. And so if we were better at finding the earlier stages, we might be able to use degree days. Degree days is just accumulating the heat units, and we know that insects need heat to grow, just like your plants need heat to grow. Another method is called phenology, where you can time what's happening in your landscape by looking at other blooms. There's so much variability in these that it's not as well worked out. And for example, is your field a north-facing slope or a south-facing slope? So it's not going to be as easy to predict. And we'll talk about another one that's even harder. But there's probably someone who has tried this, and we could look that up, but it's not widely accepted. So there must have been some limitations. And the limitations were it was a lot of effort for little return. Squash bug. It's been a couple of years since we had a really big squash bug population, but it does happen, and it happens on pumpkins and squash. These are true bugs, and to an entomologist that means they are in the order Hemiptera, and all true bugs like stink bugs, squash bugs, box elder bugs have sucking mouth parts, and they also have a simple life cycle. So the immature stage of this squash bug, after she lays her eggs, will be these little tiny nymphs that keep growing and developing into slightly larger nymphs, until they're big enough to turn into the adult stage. They are sap feeders, which means they are sucking the sap out of the leaves. Then as they do that, those leaves will wilt, and often they kind of turn black. So there's this sign that they are there. They are another one that is surprising in terms of they don't all start at the same time. They don't all lay their eggs at the same time. So you get this stretched out development that you can have all stages at the same time. You can have adults still laying eggs while mature nymphs are developing. So it's another prolonged development period. I think they're an inch long. Some people think it's closer to 3/4 of an inch, but they're a good sized bug, sort of blackish brown, elongate oval, and pointed kind of on both ends. Right now, they are outside in protected locations. That means they're in brush piles, they're in tall grass, they're at the clumps of dead leaves that have accumulated at the fence posts, they're under the loose bark of dead trees. They're out there somewhere, just hunkered down, hibernating, waiting for spring. And they are not freezing to death in those protected locations because they have just this little bit of antifreeze in their body that's keeping them alive through the winter so that they can come out next spring and resume their activity. When they come out in the spring, again, is going to be highly variable because of, did they hide on the north side of the tree or the south side of the tree? Were they deep in the brush pile where it didn't warm up as fast? So there's this huge variability of when they appear. Mating takes place in the spring. Then they begin laying eggs that are very obvious and laid in clusters, frequently at the angle of the leaf veins on the underside of pumpkin and squash leaves. So it's kind of an obvious thing to happen. They start out again very teeny tiny. They'll be green when they hatch, and they'll be about 3/16 or a little less than 1/4 of an inch long. And over the next 4 to 6 weeks, they will grow slightly larger 5 times. We call those 5 nymphal instars. Instar just means the steps of their growth. When they started, they were teeny tiny. They molded, they became slightly larger, slightly larger. They do that 5 times before developing into adults. I say typically we have one generation per year because that's what the book says. But we recall back in like 2013, 2014, they started so early, it was so hot that they actually had a partial second generation. So some years there is additional reproduction in the end of the year, but typically there's only one long drawn out generation per year when they are out there. Books mention crop rotation. For this one in cucumber beetles, I don't think you can hide your crops well enough, okay? But these things require your crop in order to fulfill their biological destiny of reproduction. They are going to keep looking till they find it. So the fact that you moved the pumpkins from one side of the plant, one side of the farm to the other side of the farm, just doesn't seem to me like it's going to do much good. But it keeps showing up, so I mention it. Removing crop residue is this double-edged sword. Maybe the squash bugs are hiding under the old stems and leaf debris on the ground, but you needed a cover crop to keep the soil in place over the winter, so removing crop residue just doesn't sound like a good piece of advice to me anymore, but it's still in the book, so we still talk about it. Gathering the eggs is time-honored, and they're easy to find. You just keep turning leaves over, and when you see them, you hit them with your thumb and squash them. It's one way to practice mechanical control to get rid of them. The other thing is to treat the small nymphs. Like grasshoppers and a few other things, like I said with hornworms, but was later had another opinion, the small ones are much easier to control than the large ones. And by the time squash bugs and grasshopper nymphs get to be about half grown, the only thing that's really going to control them well is a hammer. So this is another one where you start early, you watch for the adults to emerge, and you look for the little tiny nymphs, which were the green ones, when these sprays will actually do you some good. Now in the organic area, there's a couple of products that keep showing up, and one of them is neem. That's the azadirachtin. It's a product extracted from azadirachtin seeds that grow on trees in India. And neem oil, or azadirachtin oil, Neemex, there's a lot of different products out there, is one that is used often in organic production. It is probably a growth regulator rather than a toxicant, meaning the bug nymphs that you hit didn't die, but they stopped growing. Well, that's equally good, but they're not going to be dead and shriveled up and fall off. They're likely to still be there after you've treated them with neem. Pyrethrum is a contact insecticide that has to be reapplied frequently, and you know about that in your organic treatments. Recently, there was a combination product that put the two of them in the same product for you, and you can buy this product called Azera, which is neem plus pyrethrins together. There are also reduced risk products such as Actera and Assail that would work not for certified organic, but they would work for those of you who are seeking low input or low impact products. And then there's 14 other things you could use. The others aren't going to be organic treatments, however. So there's a lot of choices here, but when you say, I'm only going to use organic certified products, you've really narrowed it down to what's available to you. Some of the other products like Surround aren't going to work as well because they're on the underside of the leaf and harder to hit, but you do have some choices with that as well. So squash bug comes and goes. Some years it's bad, some years it's terrible, and some years it's just not as much out there. Yeah, squash bug question.
Are there any like predators of the squash bug like there are with the...
What do the rest of you call squash bugs? Do you have a different name for them? Do you have a nickname for squash bugs? You call them stink bugs. So his question, are there predators for them? Why do you suppose they stink? Their stink is their defense. So a ladybug that comes along and nibbles one little tiny nymph spends the rest of the day going and they don't eat anymore. So yeah, there are some predators. There are more parasites, but again, it's sort of like the one in the tomato hornworm. They're either going to be there, and there's not going to be an easy way to push them. Okay? Collecting adults is another thing that gets mentioned, so you could be the predator. You just go out and find them or be the predator on the eggs. Yes?
What about like floating row covers? That could be good.
Did floating row covers, they didn't show up on that one. Because of the timing and the long duration of the emergence, it may not be a practical solution because you'll have plants in bloom at the same time you have squash bugs. But for a period of the season, yes, floating row covers would be a mechanical barrier. So anytime you can separate the pest from its crop, that would be an option. So floating row covers come up a little later as maybe a better option for some other pests, but because you can't leave them on for all the whole season, it's a little less useful here. Oops. I'm supposed to talk about squash vine borer, which is a moth, but it's a peculiar moth in that it has clear wings and it flies during the daytime and it's noisy and it buzzes like a wasp. It kind of looks like a wasp. It flies like a wasp. It buzzes around your plants. The lesson for the rest of us here is if you can't be tough, look like someone who is tough, which is what this moth is doing. It's protecting itself by pretending by looking like and acting like a wasp. They are in the soil as pupae right now, under where the squash plants were last year. But when they come out in mid-June, those moths are going to fly around until they find a squash plant and begin laying their eggs at the base of the plant. Okay? So their eggs are laid on the outside of the plant, and even though they're a larvae on the inside, remember, the eggs were put outside, and then when the egg hatched, that little teeny tiny caterpillar had to chew its way into the plant to get to the succulent, juicy core of the stalk, where they live as these fat, wrinkled caterpillars, creating a lot of frass, a lot of wet sawdust, eventually causing the stems to wilt. Maybe the leaves wilt first, then the stems kind of collapse. This can be highly fatal to squash plants, and last year, it just seemed like I had more questions about squash vine borer, so they must have had a good season to get through there. There can also be larvae in the squash, and they can be out in the vines, but we always think of them as being in the stalk, so that's where you look first and see what you can do. There's usually, again, one generation per year. They don't all start at the same time, so you can have this prolonged period of them as well. The insecticides that you use will have to be on the stalk, because that's where the female moth is laying her eggs. That's where that caterpillar is going to take a bite, and that first bite had to be toxic to that caterpillar in order to prevent it from getting inside, out of reach of your insecticide. Even though it's a caterpillar, everything I've read says that Bt kerstaki, this is the usual dipel caterpillar killer, is not effective. Now, it would be if we could get them to eat enough of it, and I think the problem is they just can't get a big enough dose when they eat that first bite. But for some reason, Bt azoi, it's just another strain of Bacillus thuringiensis, sold as the product name Zentari, seems to be effective some of the time. So when we say Bt, we're no longer talking about one product. We're talking about a lot of different products of a lot of different strains. Yes? You know, it seems to have more limitations, so you really have to kind of match up that strain with its label with what you're trying to control. The other one that gets talked about for squash vine borer control in the organic market is this one called spinosad or Entrust. And again, some people think it works, some people don't. The research was sort of mixed on this one when I was looking up results, so I can't guarantee that these are going to work, but they're on the list of organics, and so you should give them a try if this has been your problem. Again, timing is the issue. How many of you can walk into the pumpkin patch or the squash patch and see squash vine borer moths? You know, it's just one of those things, once you see it, you kind of go, oh, that's it. Okay, so it's one that you can watch for, and that's when you should be spraying. There are a lot of other insecticide choices, they're just not the organic choices. Once a caterpillar is in the vine, there is one final remedy, and that is to carefully cut open the squash plant, the squash stalk with your pocket knife, dig out the caterpillar, push the stem back together, and hope that the plant lives. Okay? Now that's not going to work for a 40-acre pumpkin patch, but if you've just got a few winter squash or summer squash, that may be an option for you. When you see that sawdust coming out of the cracks in the stems, you do have that option there. Okay? This is one where row covers do get mentioned because we can put them on and keep them on during that adult flight period. We can separate the pest from the host. That's why you don't get bitten by mosquitoes at night, by the way, is because you have screens on your windows. That screen is separating the pest from its host, which is you. So we can take that concept, and if it works for you, you can separate the pest from the host. Floating row covers are one way to do that. We're experimenting with this new product called Protect Net. It is actually a net. It's not a spun-bond polyester. It's a woven net material, which is supposed to last 2, 3, 4 seasons. Should last a little longer than some of the others, but we're still looking at that one, trying to figure that out. So mechanical controls can work for some things. Squash vine borer questions? 2, okay. We'll take the guy first.
Yeah, is diatomaceous earth, is that effective on the water? You get it in the base?
You know, diatomaceous earth is one of those products that I just have to ponder because I can't come up with a good answer. In my opinion, diatomaceous earth, which he's asking about, is a great grain bin treatment where you put the little tiny microscopic bits of diatoms into the grain where the caterpillars and the beetles are crawling through it, and it scratches them to death because it stays dry. Diatomaceous earth works well under your kitchen sink and under the back of the toilet where the cockroaches crawl through it and it sticks to their cuticle and it scratches them to death and it absorbs the fat or the waxes off of their cuticle and they dehydrate to death. I understand how it works there. I cannot figure out how diatomaceous earth would be beneficial outdoors. Number one, if it draws moist, it becomes ineffective. Number 2, if it mixes with other dust, it dilutes to where it becomes ineffective. So I have trouble recommending diatomaceous earth for anything outside, but I see it mentioned a lot. And I often wonder if it's not wishful thinking to use diatomaceous earth. You going to contradict my opinion? You going to contradict my opinion on diatomaceous earth? Anybody think it really works outdoors? You know, it's got this special mode of action that they have to be dry, and it has to be dry, and the insects have to crawl through it.
If you're really desperate, you're down to excising the worms, what I do is to save the crop instead of doing that is go get a big syringe and insert the BT into the stem of the next lane.
Yeah, Angela's point is, okay, if you can't, I'll go back to that picture. If you can't bring yourself to cut the stalk open, you could inject BT into the stalk, and if the caterpillar is still eating and if the BT sort of flows into the area where the caterpillar is eating, it will digest it. How do you get access to a syringe? Oh, maybe I don't want to know. Okay. Cucumber beetles, striped and spotted cucumber beetles are a perennial pest. They are also out there in the winter as adults, doing just well. They will be out of hibernation, sitting on the fence post, watching you put your melon transplants in the ground. They will be ready for those plants as soon as you put them out there. That they come out of hibernation fairly early. They're fairly good at it. As they're feeding on your melons and on your cucumber plants, they're going to be laying their eggs on the soil. Their larvae develop in the soil, but we can't tell that that's doing anything to the crop. It is possible for the seedlings or the transplants to be killed just by feeding alone, but the second problem is transmission of bacterial wilt. Larvae are there, and then the new adults appear in July, and they just sort of hang out the rest of the summer, and we have that one generation per year. They do feed on seedlings and cause a lot of damage, so you can lose seedlings and transplants if you have a high population of them feeding at the time while the plants are still young. But as they're feeding, they are either slobbering or pooping, we aren't sure which, the remnants of last summer's meal. And last summer's meal may have included the bacterium that causes bacterial wilt of cucurbits. So they spent the winter with the bacterium in their gut. And as they're feeding, either through slobbering or pooping, they're introducing that bacterium back into your plant. 3 weeks to 6 weeks later, when those vines start to run, the plants will collapse because the bacteria has taken over the vascular system, and there's no bringing these plants back. And to prevent bacterial wilt, you had to control the vector, which are the cucumber beetles early in the season. Here's another one where the book mentions crop rotation. I think cucumber beetles are smarter than we give them credit for. They will find the cucumbers no matter where you hide them. Floating row covers could protect you for a brief period of time in the spring, and maybe that's all you need. But remember, the floating row covers or the treatment has to begin immediately. You can't say, "Whew, I got the transplants in the ground, now I can take that 3-week vacation and come back and they'll be grown up." The treatments need to start right away on that. Trap cropping gets mentioned, and I'm not sure this is practical for most growers, but it's in the book, so you can talk about planting a ring of blue Hubbard squash around the outside of your crop. Blue Hubbard is one of a couple of squashes that are just super attractive to cucumber beetles. So they will start there as they're flying in from the woodland, as they're flying in from the fence rows. They will stop there. The question is, what are you going to do with them there? If you were not an organic farmer, you would spray the heck out of that trap crop and you would kill the beetles where they stand. Trouble is, as an organic farmer, you don't have a good option for killing the beetles on the Hubbard squash before they move to your crop. So what good did trap cropping really do if I can't stop them there? Okay, maybe I could get enough of them on there and flame it or mow it or do something to kill them where they are. But the whole trap crop philosophy is I can keep them over here where I can kill them so that they don't get over here where I'm trying to make money. And that's going to be much harder to do in an organic system. Kale and clay, sold as a product called Surround, and pyrethrum are organic treatments that are mentioned. The non-organic treatments have a whole long list of insecticides, including some systemics that they put on the soil that are taken up through the roots and kill the beetles as they feed on the plants. Okay? Those neonicotinoids are not organic certified by any means and probably won't even last that much longer. So it's not a good, it's not an option for the rest of us. Yes?
What's the one that they use as a seed treatment that starts with an A?
There are several seed treatments now for field crops. Imidacloprid used to be one of them. The other one is, oh, used to be Merit. Huh.
Anyway, it's a neonate.
Neonicotinoid, yes. Mm-hmm.
Did you say that they do not do, the larvae do not feed on roots?
They probably do, but the plants are growing so well that we can't tell that it stunts the plants. Should we kill the larvae in the ground? It probably won't make any difference. So how do you know when you have cucumber beetles? You could put out yellow sticky traps. You could just walk around a lot. There are other ways to do it. What we have found is kind of the middle of the day is when you need to be out there looking for cucumber beetles. If you go out at sunrise and it's still cool, they won't be up yet, so you give them a chance to wake up. And then you count them, and when you find cucumber beetles, it's time to put on your protective sprays. It doesn't take a lot of cucumber beetles to cause a problem for you, especially with the bacterial wilt. Okay? So which one of these is not a cucumber beetle? Well, spotted cucumber beetle's obvious, so let's take that out. Of the other two, which one of these is not a cucumber beetle? Okay? There are two insects in the fall of the year that look surprisingly alike. One of them is the western corn rootworm, and the other one is the striped cucumber beetle. And there's a lot of misidentification. It turns out it's not a big issue. They're both on your pumpkin vines. They're both feeding on the flowers. They're feeding on the pumpkin rinds. But western corn rootworm is going to die before freezing. And they're going to lay their eggs in the cornfield and be a problem for corn farmers the following year. Western corn rootworms have sloppy stripes. Sometimes the stripes meet in the middle, but they're always kind of curved and they're kind of irregular. The cucumber beetle always has perfect stripes. Okay, so that's an easy one to see. If you're really into it, the western corn rootworm, the tibia, which is the middle section of the leg, just like it's your lower leg section, the tibia is the middle section, it's black, and on the striped cucumber beetle, there's some yellow in that tibia section. So two beetles that kind of look alike and kind of nice to know the difference. Striped cucumber beetle is the one that's going to wait in the winter, and attack your crops the following year after they've reproduced. And corn rootworm is not a pest of cucumbers and melons except in the fall of the year. All right, the one you waited for. Yes, go ahead.
Do they only go after cucumbers and those things?
Striped and spotted cucumber beetle are on all cucurbits, but it seems like muskmelons are their favorite. But they can be on pickles.
I didn't do cucumbers one year or any of that stuff because of those things. I had beans and things that looked like that. Is that something that they might do?
Could be either, especially in the flowering stage. Yeah, could be either. Yes.
Has an oil spray ever been tried on the trap crop around the cash crop?
Oil, that's a good idea.
Because if you're not interested in the trap crop anyway,
Right. You're not going to harvest it, you're going to plow it down. Some sort of an oil spray. You know, the other one that comes to mind is insecticidal soap, and as we're talking about insecticidal soap, looking at a picture of a Japanese beetle, I think insecticidal soap is a hard way to kill a hard-shelled insect.
or like a summer horticultural.
Horticultural oil would be worth a try. When you do that, only treat one side of the field. So you can tell us what happened in the other side that you didn't treat. Japanese beetle has become a favorite of everybody. And I put this picture up just to remind you that there are two different insects out there with similar names. The multicolored Asian lady beetle is a ladybug. Lady beetle, ladybug are exactly the same thing. Multicolored Asian lady beetle is one of 500 species of ladybugs found in the United States. It's the one that came here in about 1994, moved across the country all by itself. Nobody brought it here, nobody introduced it, nobody spread it. It took care of getting around the countryside by itself. It eats aphids in fields and trees and gardens all summer long. And then in the fall of the year, this is the one that comes into the house. Okay? Japanese beetle is the scarab beetle that feeds on flowers, fruits, and foliage of plants. Okay? About 1/2 inch long, metallic green, coppery wing covers, and so forth. It's happening less now than it used to, but it used to be a few times a year someone would call me in October. They made a long-distance phone call to talk to an entomologist at the university, and their question was, how do I get rid of the Japanese beetles that are on the side of my house? And I would say, oh, you mean multicolored Asian lady beetle? And they say, yeah, that's what I said, Japanese beetle. So there was this confusion about names. The insects are nothing alike. But there was a problem when both of them were new, which is becoming, I think, less of a problem. What's the difference? And the difference is really quite obvious, but the names were similar enough that some Iowans had trouble telling them apart. Well, the Japanese beetle, as a beetle, has a complete life cycle. Eggs are laid in sod in June and July. Then from August to September, they start out as a little 1/4 inch grub. They very quickly grow into a 3/4 to 7/8 inch long grub. And then they stay in the grub stage during the winter, make the pupa the following year, and June and July they come back out. We call these one of our annual white grubs because they have one life cycle per year, and it takes 1 year to have a life cycle. And so here's a schematic of where they are. There is eggs in the soil in June and July, then larvae in the sod, again feeding on grass roots, through August, September, and into October. And then finally they go a little deeper into the soil where they can wait out the winter before coming back up in the springtime and turning into the pupa. So your problem, primarily as a vegetable grower, is this adult stage in June to August. The turf grass growers have problems in August, September, and October with the grubs that are feeding under the ground. So everybody gets to suffer from Japanese beetle. It is an equal opportunity offender. Okay? So the adults feed on the foliage, flowers, and fruits. Some people say 350 different kinds of plants. Some people say 400 different kinds of plants. Whichever it is, it's a lot. They're not picky eaters. They will be on most everything. But what are their favorites? On your farm, what is their favorite food? Asparagus, raspberries, peaches, if they stay alive. Sycamore leaves, cherry leaves. By far and away, their favorite host in the entirety of the state is linden trees. Okay, so linden trees that are planted thickly alongside the highways and streets are one of their favorite foods. Oddly enough, one of the foods they don't eat are ash trees. So there's your answer, plant more ash. Oh, wait a minute, that's got its own problems, doesn't it? Okay, so it's in the adult stage that they're feeding on the foliage and flowers and fruits, and I think this is the list that you pretty much said. Starting with asparagus and beans and eggplants. They'll also feed on herbs just by chewing holes in the leaves. And when they feed on the leaves, it's not that they start at one edge and eat across. They eat between the veins and leave the veins alone. They leave the skeleton of the leaf in place, so it's called skeletonization. Okay? Okra, sweet corn. Interestingly, in sweet corn, they're only a problem if they're feeding on the silks prior to pollination. Once pollination has occurred, the Japanese beetles aren't going to hurt the sweet corn crop. But there's a long list of everything else, and I could have put raspberries up there as well, because they're also on fruits. And here's another picture of that skeletonization that we were talking about. And they do feed on the fruits themselves, the raspberry berries, the peaches and the apples as well. They'll even feed on aronia. So if you thought you were going to solve your Japanese beetle problems by plowing everything up and planting aronia berries, you can't escape Japanese beetles. They will be there too. We have watched Japanese beetle in the state of Iowa since 1994. We have watched it in the United States since 1916. So even though you saw Japanese beetles last year for the first time in your life on your farm, you're not the first to see it. It has been here since 1916 and moved across the United States. It was found in Davenport, Iowa in 1994. And since then, we have found it in about 63 different counties. There are parts of Iowa that still have not reported that they have it. Okay? So if you're farming down south central, or if you're farming up in the northwest and you find a Japanese beetle next year, pull out your cell phone, take a picture of it, send me the picture, and then my map will have another red county on it. I love making red counties. Okay? This is what's reported. This doesn't mean they're not in the white counties. It just means no one has bothered to tell us yet. So this sort of explains a little bit about it, that not everybody has them, and just because your county is colored in doesn't mean you've all had them the same time. It tends to be very spotty. Japanese beetle will show up in one place and it won't show up somewhere else. But when they show up, they go through what's called the typical invasion cycle. You go through your life, you have none. You've not had any yet, have you, Tim? Nope, you got none. Someday he's going to find one. And he's going to say, oh, what's that one? And the next year there'll be 100. And the next year there'll be 10,000. And the next year there'll be 1,000,000. And it will explode over a period of years, giving normal weather. Okay? There are some variations that can happen, but this explosion happens spot by spot by spot. In my backyard, on my climbing hydrangea, it happened in 2004 to 2009. Then I went for several years and didn't see any. So it's not always going to get worse. But when you're at the beginning of that explosion, you feel like your life is ending. You've lost your reason to live. It's just going to get worse and worse and worse forever. No, it peaks. And then it drops off. But some year it will peak again. So they will go through these modulations of ups and downs once you make it through that explosion. But everybody goes through the explosion at a different time. How many of you have not been through the explosion yet? A few of you. How many of you have been through it and survived? There you go. There's the hope. For those of you who haven't seen it yet, or for those of you who saw it for the first time in the last couple of years, there is life after the explosion. You just have to get through it. Yes?
What's their flying distance?
How far will Japanese beetles fly? Let me make up a believable answer. 2.25 miles. A long distance, a long way. Now, this is getting ahead of where I'm going to get, but in answer to her question, the people who fight Japanese beetles the hardest are Iowa golf courses, because the grub kills their turf grass, and if your golf course has brown turf grass, people don't want to play golf. They're just that finicky. So they spend hundreds to thousands of dollars every year to make sure there are no grubs in the grass on the golf course. An 18-hole golf course is about 100 acres. The linden trees in the middle of an 18-hole golf course are still defoliated by Japanese beetles. So they have come from outside of a 100-acre area.
Do you think they just bump into it, or do you think they're attracted by, I had them on kale last summer.
Yeah.
Late in the summer, which is crazy. They were just, kale was just absolutely loaded with, they were nowhere else. Do you think they searched it out?
A couple of things happen. Japanese beetles find food sources at long distances by noticing ultraviolet radiation, the colors that come off of it. So they're attracted to the area. When they get closer, there will be chemical cues from the plant that say, ooh, eat this. And so there's a combination of things. Now, one of the things is that if the plant is already damaged by Japanese beetles, more Japanese beetles will come because that plant smells good. They will gang up on the same plant. Yeah.
How many years does that explosion last? I mean, we've had really, really bad years.
Yeah.
I'm hoping it'll go downhill.
You know, I don't have a great answer for you. My own personal experience was only 5 or 6 years. The book says 5 to 10, something like that. So you could be there for a couple more years, but it will come. But there are some things along the way. One of them is the fall and winter of 2013, 2014. It was so dry in late 2013 that the Japanese beetles suffered as grubs in the ground. Then the winter of 2013-14, the cold, the frost in the soil lasted so long that the survivors didn't make it. So we came into the spring of 2014 with very, very low populations. Hardly saw any in the state in 2014. Saw a few in 2015. By 2016, the explosions were back. So there will be these temporary lulls as we go along. What can you do about Japanese beetles? One of them is tolerate the damage. And this is much easier to say to people who have a tree than it is to people who have a vegetable crop, because trees are not killed by defoliation. Every deciduous tree, and I can see from here, has defoliated, yet they are alive. They will come back. So defoliation of deciduous trees is not death. So one of the things, if it's possible, you could tolerate the damage. You can use screening, floating row covers, little boxes, little cages. One of my favorite stories is a rose grower in Illinois who raises buds that he sells. He sells rose buds. And he makes little bonnets out of bridal veil fabric and covers each bud. Because buds are that valuable to him, then he's using some kind of a screen. So he's got this basket full of little bonnets that he goes out and he ties on the rosebuds as they're coming open. This is like Chicago voters. If you're going to use chemical control, it's not going to be one and done. You're going to have to start spraying early, and you're going to have to spray often. Again, the adults appear over an extended period of time, partly because of the way they're coming out of the soil. So how many sprays do I have to use? Oh, at least 2, maybe 4, maybe continuous spraying to get you through to kill them, because they just keep coming. It's not that the spray didn't kill the ones that were there. More just keep coming in. So there is no one and done. Insecticide sprays are going to have to be repeated. Organically, kale and clay is a repellent that doesn't kill them, but it stops them from feeding in that area. And as near as we can tell, azadirachtin or neem is a repellent to Japanese beetle adults. I've got one more to tell you about in a little bit, but that's my organic list for now. My non-organic list is as long as my arm, by the way. There are lots of chemicals you could apply to Japanese beetles in a traditional farming system.
How about pheromone traps?
Pheromone traps are good for catching thousands and thousands of beetles out of millions and millions. So you catch 10,000 beetles and you feel pretty important. Look at this 10,000 beetles that I caught. There's still a million out there, and they're still coming. So trapping Japanese beetles is like bailing the ocean. I can stand with a bucket and get out a lot of water, but there's still a lot of water left, and that's what the traps do as well. So it may be emotionally satisfying to find all these dead bugs and all these dead beetles in your traps, but it's not doing you any good to speak of, especially if you're in the outbreak. If you're in the explosion, it's just not going to matter. It might, if you don't have very many, it might make a difference, but I'm not even going to recommend it then. So we don't recommend the traps except for one purpose, and that is to make yourself look like a generous person. buy the trap and give it to your neighbor. Because the traps attract more than they catch. And so you want the Japanese beetles to go to the neighbor's property and feed over there as much as you can. So it looks great to catch 10,000 beetles a day, and you have to expand the trap, and you put the trap on top of a garbage can because you're catching so many beetles. You're just not making a difference. The master gardener in Lynn County, by the way, can tell you what not to do with your trapped Japanese beetles. They do not make good mulch in the garden because they stink. Okay? When they die, they smell like dead animals. Oh, they are dead animals. Okay. So we don't recommend the traps. Very popular. People love them. They feel like they're doing something. They're just not making a difference. What about, yeah?
If you have a small area, you can, and they're thick on a plant, you can take a bucket of soaping water, like put some Dawn in it,
Yeah.
knock them in there before they, because they're not real quick to fly. They're kind of like, whoa, somebody's feeding on me.
I didn't say hand picking here, did I?
They drown.
Yeah.
And
Hand picking is an option, just like screening is an option. Japanese beetles play possum. As soon as you get close to them, they pick their legs up and they fall. I think part of the reason people hate Japanese beetles so much is because they're always, as entomologists say, in copula. Okay? That you go that you go up to the plant and there's two of them. They're hooked together and they're having more fun than we are. So I think that's why we hate them so much. So what about killing the grubs in the ground with an insecticide in the sodded area? I mean, they're not in your tilled fields. The grubs are in the sod. What about treating the sod with insecticide to kill the grubs so I don't have beetles the following year? Will not work. The golf course is my example. 100 acres of turf grass with no Japanese beetle grubs, and they're on the linden trees in the adult stage. They are so mobile. They are such good flyers, and I don't know what the exact distance is for flight, but I know they get around very well. Okay.
My observation has been that people in town suffer much, much more than I do from them. And I think maybe being surrounded by cornfields might actually limit their presence a little bit.
People in town tend to be surrounded by a lot more sod, and that's where the Japanese beetles reproduce, is in turf grass. So here's the answer: plow up your turf grass and plant more flowers. So controlling the grub will not prevent the damage to your plants in the adult stage. Controlling the adults will not protect your turf grass. So golf courses still have to treat the grass, and vegetable farmers still have to treat the crop. You can't kill one stage and hope for a carryover effect on the other. Okay? What about pathogens? There's a few of them out there. Yeah, we've talked about these before. One of them, there are pathogens, nematodes, and parasitoids that take their toll. Certainly these are out there. You don't have to do anything. There's already these biological controls working for you. And if they killed half of the Japanese beetles, it wouldn't be enough. So we need something that gets to us to more than half. Entomopathogenic nematodes I talk about only because saying the word entomopathogenic is so satisfying. Okay? Entomopathogenic nematodes are beneficial. These are good nematodes. Normally you don't like nematodes because they attack your plants. These are nematodes that attack insects. Okay? They need a warm, moist soil that is always warm and moist. So they tend to work in Louisiana, Mississippi, and Alabama. But up here, our soils alternate between frozen and drought, and these nematodes really don't work very well. You need 1 to 2 billion nematodes per acre, which means we're really questioning whether this is going to be efficient or not. And the last time I looked up to buy Steinerema felicae on Amazon, I could buy 10 million nematodes for only $16. That would cover 200 square feet. You know, that's a lot of money to cover the size of your vegetable patch or the size of your turf grass sodded area in hopes of killing these Japanese beetle grubs that way. So and that's not likely to work. What about, it's now called Pinobacillus papilii. It's the milky spore disease, which gets great reviews on the internet from people who don't have Japanese beetles. Okay? The research going back into the 1940s and 50s indicated that generally you'd get a little control and occasionally you'd get a lot. Again, we're using a living bacterium that's going to attack grubs in the soil. What about the year you don't have any grubs? The bacterium disappears and you have to reapply it? We aren't sure. But we can't find any good reason to recommend milky spore in the upper Midwest. Okay? There are people who swear by it, but we can't find that they've done a replicated study. And as we look back over, well, this is 60, 70 years of research results, it has not held up in the upper Midwest. So we don't recommend milky spore disease, and I know that's disappointing to a lot of people who think there's an easy answer. They think there's an easy biological answer, but it's just not going to be that quick and easy. Okay? But there is another bacterium that has just come on the market in the last 3 to 5 years. It's another Bacillus thuringiensis. This time the strain is Galeriae. Okay? BTG, Bacillus thuringiensis Galeriae. That's the third strain of BT we've talked about today. It's sold under a product cleverly named Grub Gone. And what research has found is 50 to 75% reduction of the beetle larvae in the sod that was treated with it. Unfortunately, you're buying a living product, and sometimes all of them are alive, and sometimes only part of them are alive. Variation is an issue with these living materials. So if you were looking for grub control, this would be an option. And as long as you're doing good tillage, as long as you're doing good grass weed control, you really don't need to treat grubs in your vegetable production. Now, drum roll, the same people who put BTG in a granule for the soil put it in a powder form that you can spray on the plants to kill the beetle stage. This is one of those things that entomologists say, nah, but we're wrong. It does work. If you spray beetles with this BTG, they do die. That doesn't make sense to me. But the research is there saying that there was a good reduction of Japanese beetle adults until it rained. Stanton Gill is one of our leading ornamental entomologists in the United States. Okay? So Beetle Gone is the same active ingredient as Grub Gone from the same company, but sold in a different formulation for treating above ground. So here's a product that, in my opinion, should be organic. You'll have to check with your certifying agencies to see if they agree with me. But we're looking at an organic or a biological control that does seem to be working. Is $130 to $150 for 2 acres a good deal? Is that a good price? Or is that as expensive to you as it sounds to me? That's kind of high. But you know, you don't have to treat everything. You're spot treating where the Japanese beetles are feeding, so this may be a value to you. Unfortunately, this product may not be available for 2017 because they've already sold out. So get this, quote, they are ramping up production. What happens when you expand production of a living product to grow them as fast as you can? Inconsistency and variability creeps in. So I would be worried about this in the next few years, that are you really getting a product that's going to do what it says it's going to do, or did you get the result of somebody's ramped up fast production? Quality control of these living materials is really an issue to watch. Okay? Anybody tried Beetle Gone? What's your question anyway?
Question I have, I guess, you mentioned 3 different types of BT. I'm just curious, now we have Smart Stack corn or whatever, you know, it has either 5 BTs in it or 7 or however many traits. Do you know, are these 3 types you talked about, are they 3 of the types genetically engineered in the corn plants for rootworm? Are they the same one?
Even in BTK, Bacillus thuringiensis kerstaki, the caterpillar killer, there are, I don't know whether to say dozens or hundreds, there are lots of strains of BTK. Even this one, BTG, there's more to it. It's like BTG 305 or something like that. So there are literally thousands of these strains. As far as I know, the ones I've mentioned are not in corn, are not in BT crops. But if there were money to be made, they would try it. Another question in the back? Yeah.
Yeah, am I right in assuming that these products will also take care of some of our predator beetles, which we really rather not use?
You know, that's a good issue, and we normally think of BT products as selective. BTK is selective for caterpillars. BTI is selective for mosquito larvae. BTT, Tenebrionis, is selective for some beetle larvae. This one is supposed to be selective, and then earlier this year, earlier in 2018, University of California at Davis issued a warning not to spray this on plants and flower. They think there's an impact on honeybees from this BT. What? That's not supposed to happen. But there are BTs that are toxic, chronically toxic to honeybees. So there's a whole lot we don't know, but we're going to limit the application to just those infested plants. And there's not going to be a lot of lady beetles where the Japanese beetle adults are feeding. So I think we got a bit of a pass on that one. Okay. What else can I tell you about Japanese beetles that I haven't already made up? Yeah.
So like if you know, plant in the spring, you kind of grub or maybe whether you put it in the ground. Would you suggest just killing it? Or is it, there's so many different things, like, so, I don't know.
Well, that's right. Just in the white grub.
His question about, are you going to kill our beneficial beetle larvae if you're putting down the product? It's the same thing. It's not going to have a huge difference, obviously, but you're looking at it. So.
If you're digging in the sod, or you're digging at the edge of a field close to sod, if you pull out a white grub, you're going to know it's a white grub. Then it's going to be one of two species. One of them's harmful to you, one of them isn't. So can you tell them apart? I can, but I have a microscope at my disposal. So, there's a certain amount of emotional satisfaction to pulling a cutworm out of the plant and throwing it across the fence row. Makes you feel good, but you didn't change the world any. So go at it. Or some of these make good fish bait. That's your cue to go fishing. Yeah. The female beetle prefers to lay her eggs in moist sod, grass, thick plant material. I'm sure there's some out on the prairie, but by and large, it's where the grass is growing. It's your paths, it's your fence rows, it's your lawn. Where you till, and there are no grass roots, where you control grassy weeds, and there are no grass roots, these beetle larvae will not survive. They could be. We don't tend to find Japanese beetles in fields as much as we find them in maintained lawn. Was there another question? Yeah.
Well, since you can't totally eliminate the Japanese beetle from the economic crops, would it be a good idea just to plant their favorite stuff and then just let them go like that?
That's the trap crop. That's the trap crop theory. And if I surrounded my vegetable patch with linden trees, maybe they would go to the linden trees first, but my next question is, where are they going to go when they eat all the linden leaves? So have I attracted them in from the county to my area, and now they're going to move there? If there were a way to move them over to somewhere else, like the linden trees, and kill them, that would make sense. But just to attract them over and feed them doesn't seem like progress. They're still there. They're still eating. Yeah.
I've seen a certain type of weed under my apple trees, and they seem to love the weed, and they don't chew on the apple trees nearly as much.
Yeah, you're lucky. Yeah. Orchardists do have to control Japanese beetles on occasion too. They feed on the leaves. Mm-hmm. Peaches, they feed on peach leaves. Okay. Coming to the end, Colorado potato beetle. Is this a problem? For some people, yes. For some people, no. The interesting thing is, at least when I was a kid, everybody knew about potato bugs. And we all made a penny a bucket picking potato bug larvae off the potato crop. And then I came to Iowa, like I said, 40 years ago, and the question I got from people was, what happened to the potato bugs? I don't see them anymore. Well, 25 years later, they returned. So they were here, they were gone, they're back, and now it seems pretty spotty where they are. It's called the Colorado potato beetle, so it's just one more thing to hate Colorado for, although it's not their fault. Easy to identify because of the 10 stripes. In fact, the scientific name describes them. The scientific name is Leptinotarsa desalineata. Desalineata. It even sounds like 10 lines. Okay, so desalineata is the species name of the. So these alternating black and yellow or brown and yellow stripes are pretty easy to identify. Very humpback, not squared off like the Japanese beetle at all. And then they lay their eggs and turn into these soft humpback larvae that grow up to 10 millimeters, which is a little less than half an inch. And they start out, they're very red when they first appear as little tiny, less than quarter-inch long larvae. Then they turn kind of yellowish red as they grow, and finally they're orange with black heads and legs and these spots along the sides of the body. So it's easy to identify. The life cycle is the adults find your potato crop. They lay clusters of eggs that are kind of obvious on the undersides of the leaves. The eggs hatch into larvae that begin to feed. The larvae feed for a while before they drop to the soil to make a pupa. The pupa transforms to the adult beetle, and we start the process over, and it goes around and around. Generally, in Iowa, we get at least 2 full generations of that per year. Egg, larva, pupa, and adult. Egg, larva, pupa, and adult. Well, that happens twice, so you get to fight them twice. Right now, they're out there waiting for the crops to come up. They'll emerge in May and start to move to the fields, begin to lay their eggs. Larvae only feed for about 2 to 3 weeks. But again, they didn't all come out of the soil at the same time. They didn't all arrive in the potato patch at the same time, so you have larvae over a long period of time. They're all not, it's not one and done like some other things. New adults emerge 2 to 3 weeks later and repeat the cycle in the second half of the summer. This is an interesting insect in that we kind of blame Lewis and Clark expedition for part of this story, but it originated in central Mexico, but it was discovered in the United States at about the time of the Lewis and Clark expedition, slightly after, because it was named, it was found in 1811, but it was named in 1824. Described means we put a name to it. And when it was found along the Missouri River Valley, it was feeding on buffalo burr, which is a weed that grows on the sandy shores of the river. Nobody noticed anything for 40 more years. After we found it on feeding on buffalo burr out here in the Great Plains, nobody worried about it for the next 40 years. Suddenly, European settlers moved across the continent and brought with them their potato plant. We brought the crop to the pest. Normally, the pest comes to the crop, but in this case, the European settlers brought the potato to the Great Plains, and 100 miles west of Omaha in 1859, the Colorado potato beetle had moved from buffalo burr to the related plant potato. Okay? So we brought the potatoes out to the pest. It wasn't named Colorado potato beetle until 1867, partly out of this mistaken notion that Lewis and Clark had found it, but it was really after their expedition. But get this, we found it on potatoes in 1859. In 1874, it had reached the Atlantic Ocean. It went back upstream from potato patch to potato patch and reached the Atlantic Ocean in 15 years. Okay? That's pretty fast movement for a beetle. That was hoofing it across the country. Okay? So what can we do with Colorado potato beetles? We don't really have resistant varieties. The biological controls kill a few of them, but not many. What we have left are some things like tolerating the defoliation. What does that mean? Well, that means before the plants flower, you can lose 1/3 of the leaf matter and it won't hurt the yield. This is the same with soybeans. Soybeans can take great defoliation and not hurt the yield. So the first generation, you can put up with losing a third of the leaves before you have to do anything. In the flowering stage, the plants are a little more sensitive, but then in the tuber fill for a period of potato growth, you can put up with that defoliation again. This and other information is in the Midwest Vegetable Production Guide for commercial growers. This includes organic information, but it is not an organic publication. All right? So one of the things you could do is tolerate. Oddly enough, our East Coast potato growing friends say that when they moved the potatoes a quarter mile away, it helped. So in this case, crop rotation, quote, as far as possible, seems to make a difference. And it's partly because the beetles aren't really good at flying in the springtime and they disperse at random. They may get to that potato patch half a mile away, but it's going to take them longer to get there, and by that time the potatoes have grown a little more. So this is one where we do talk about crop rotation. We also talk about trap cropping, where you could plant a border early. If you could kill the potato beetles on that trap, you might save yourself some of the crop, but it's going to be hard to kill those beetles with an organic treatment other than something like flaming or disking to kill the larvae before they mature. There are lots of insecticides, and we need to put those on at the right time. And again, treating the small larvae is going to be the most effective. Okay? Eggs are not susceptible to insecticides, so we need to wait for them to hatch. And timing becomes a problem because of this staggered appearance and staggered emergence of the beetles. And there's this extended period where eggs are being laid, an extended period where the eggs are hatching. So how do you know you have Colorado potato beetles? You get out, you turn over the leaves, and you look. And you do that regularly, frequently, and thoroughly if you're thinking of fighting Colorado potato beetles. If you can fight them early, you get a better control than if you wait until August and try to play catch-up. Okay? So there's a whole lot of things that go into that that you might consider. At least in the reduced risk pesticides, we've got some choices like spinosad, we've talked about in trust before. This product called Ramon is an insect growth regulator. That means it's a hormone mimic. We put the hormone on the plants and the insects don't develop. Here's another BT strain, BTT, Bacillus thuringiensis tenebrianus. Okay. So we've got some choices if they're available to your certifier, if you're organic, but beyond that, there's this long list. Now, the other problem with Colorado potato beetle is they treated the potatoes in New Jersey with the same insecticide for so long that they're resistant to some products. So not everything will work as well as you might think it would. Let me finish with corn earworm, just because you might be a sweet corn grower. The same insect is called the tomato fruit worm and the cotton bollworm. One insect on 3 crops. Okay? Corn, tomatoes, and cotton. It does not live here during the winter. All the corn earworms that were in Iowa last year are dead. The ones down south on cotton are still alive. Well, maybe they froze to death in the last few weeks, but they're doing okay down on the Gulf Coast of the United States. So next spring, when the spring rains come out of the south, corn earworm moths will be blown here with the rain. When that happens, we don't know. We can't predict it because it's such a variable thing. So when they arrive, they're going to be attracted to lay their eggs on green corn silks. So not until the crop is tasseled will your crop be at risk. And once the silks have turned brown, it doesn't matter. If there were moths in between that little window, your crop was vulnerable to the eggs being laid on the crop. Eggs hatch into little tiny caterpillars, which follow the silks down into the tip of the ear, where they feed for 3 to 4 weeks. About the time you harvest the corn 21 days after tasseling, you got it on the tailgate of the pickup truck, and everyone's peeling back the ear to see if there's a big fat caterpillar in your sweet corn. It's been there for 3 weeks at that point. And the only time you could have controlled it or prevented it was back when the silks were green and the moths were present. Okay? Anybody ever try this thing called zeolator? A manual applicator where you go along and you squirt oil into each ear? Whew. It's a lot of work. But it is one of the organic options. Otherwise, we would be spraying at the time the moths are present and the silks are green. We often have to spray again, at least once. Okay? And how do you know if the moths are present? You could be using traps, or you could just take your pet. Commercial sweet corn growers are facing a problem that the cotton bollworm down south is being treated with pyrethroid insecticides, and it's resistant. So not every insecticide works anymore. This isn't true of the organic products, but if you're a traditional grower, this would be a problem for you. There are traps available if you really needed to know more about it. Okay? Going to take our last few minutes here to give you my name and address. We didn't need to talk about that. In case you need to call or write. I can give you the name of the president if you want to complain, but what else do you have? Angela.
What about the fruit flies that are in the raspberries, new fruit flies?
You got this answer down? Spotted winged Drosophila is a fruit pest. I was asked to talk about vegetable insects, so I actually left it out. But she asked. This is a game changer for raspberry growers, and commercial raspberry growers are going out of business rather than face this pest that has only been in the United States since about 2000, continental United States since 2008. And the female has a saw blade for an ovipositor with which she slits raspberries, blackberries, blueberries, and she lays her eggs inside, okay? And her eggs then turn into larvae, which turn the raspberry to mush. Unfortunately, the control for this is spray when flies are present and keep spraying throughout harvest. And that's not a good answer, and some people are giving up growing raspberries instead of taking that answer. We're looking at alternatives to control, but right now what we have are insecticides to keep these larvae from developing inside the fruit. You can trap for them. That's how you know when the spotted winged Drosophila is in your raspberry patch. You put out a trap that contains either apple cider vinegar. Yes, the slides are all screwed up because I changed the format of the slides after I got to the meeting and saw the size of the screen. You can use the traps, and if you find flies in the traps, it's time to start spraying to protect the raspberries. For home gardeners, if you're growing just a few raspberries for yourself, what we tell you is, oops, I wanted a picture of a larva. If you have just a few raspberries, pick them very frequently, like every day. Go out and take the ones that are almost ripe and eat them quickly. Don't set them on the windowsill for 3 to 4 days because they will turn to mush. But if you eat them quickly, before the larvae have a chance to grow, you'll never know they're there. Yes. We think they overwinter in the fly stage, but we're still a little vague on that in the upper Midwest. Yeah. You know, we've got a few reports on blueberries. We've got a few reports on aronia. It's like raspberries and everybody else so far. Yeah. And do you see them equally in both crops? Seen them in the raspberries. Part of it is the thickness of the skin. That if you had to saw with your tail to lay your egg in a fruit, you would pick raspberries rather than blueberries. At least I would. Yeah, back here.
Is there something that's changed that's made our environment more readable to them? Why weren't they here 5 years ago or 10 years ago?
Why are they here now and they weren't here 5 years ago? I think we were really lucky. They were in Hawaii for decades before they were found in California in 2008. University of Iowa and Iowa State are arguing, by the way. University of Iowa says they were here in 2009. We say they were here in 2010. We can't beat them in football, but maybe we can beat them in spotted winged Drosophilus. So that, and then they finished crossing the United States in less than 7 years. So I don't know that anything is particularly conducive other than the fact that they got here and went crazy. Let's go back here. Wasn't there a question? Yeah.
Can you show us a brown marmorated stink bug?
Sure. I skipped over that one.
One?
Just one.
Because
You probably are. They are in the state of Iowa.
Lynn County, they say we have them.
Yeah, brown marmorated stink bugs have been found in the state of Iowa since 2011. They've been in the United States since about 1998. We have found them in all of these counties as a household accidental invader. Now, where they occur in the eastern United States, they are a pest of crops. And back in 2010, the state of Virginia lost $10 million worth of apples from these stink bugs puncturing the fruit and feeding on the sap. We have not had reports of fruit and vegetable damage yet, but they do feed on everything. And they feed on the sap by puncturing the plant.
Go back to that slide where they're not, that one, no, that one.
That one? That's the squash
No, the
bug.
next, go to the next one. You had one that said not brown marmorated stink bug.
Oh. We have brown stink bugs. It's called the brown stink bug. Or it's called the one-spotted stink bug. This one, called the spine soldier beetle, spine soldier bug, is a beneficial predator that eats other insects. You like that one.
It is really hard to tell that middle one from.
Oh yeah, it is hard. I look for this line in the end of the wing. The spines on the edge of the edge of the shoulders aren't really just enough. Over here.
Do you foresee CRISPR-Cas9 being used to control pests in the future?
You know, CRISPR is the gene splicing movement technique that may revolutionize everything we know and do. I'm not in that game enough to have a good opinion other than it sounds exciting when the advocates talk about it.
I mean, you can't really sell that to somebody, you know, so it's like, how much money into developing it, releasing it, and then hope it works, I guess.
Yeah. He brought it up. What if you could tell people that I can give you perfect sweet corn that has never been sprayed? Would they buy it? What if you told them it was GMO sweet corn? Would they buy it then? You know, we've got some alternative technologies out there that are giving us new ways of controlling pests that may have real consumer pushback. But BT sweet corn is one of those that we've talked about now for a long number of years, that you don't have to spray for corn earworm because the plant kills corn earworms because of the proteins that it produces because of the genetic modification. So CRISPR is another one of those. If we genetically modified mosquitoes so they explode upon drinking blood, wouldn't that be a good thing? Yeah.
Well, so that with the BT sweet corn, it sounds like I like the science behind a lot of that, but in practice, it'll last for 10 or 15 years and you'll have resistance and it won't work anymore. So really it's just a seed company trying to sell you something.
Stick it to the man. Good place to quit. Thank you very much.